All right, so we're taking a look at Park Practice Unit 2, and we're looking at problem number 3. I don't know. I don't find anything more fun than taking a look at two cars and comparing their gas mileage. Can't beat that. No siree. All right, so the gas mileage for two cars can be compared by finding the distance each car traveled and the amount of gas used. The table shows the distance that car M traveled using X gallons of gasoline. The graph shows the distance Y that car P traveled using X gallons of gasoline. All right, so, well, I'm looking at this table and, well, I see the table doesn't go in order, but I see that, it goes up by 1 here. Going this way, it goes up by 2 if we go opposite ways. And we're being asked to find the miles per gallon. All right, so, okay, how far it goes in a mile again. So here's what I'm gonna do. I'm gonna pull up my calculator here. And, all right, it's looking good. All right, so I'm gonna now say, all right, so let's subtract 80.5 or 50.4 from 80.5. And because there's a difference in 1 mile there, so let's see what we got here. So 80.5 minus the 50.4, and that gives me 30.1 gallons of gas. Okay, but that's only between one data point. So you know what else I could do? I could take the largest data point, which is the 7, and divide 181.3 by 7. Now let's see if I get a number that's similar to that. So I'm going to clear this by getting rid of it and bring up a new calculator. And that just went away because it's being difficult. All right. So, of course, the phone rings when I... All right, so back. So I'm going to take that 181, and of course, is there a back arrow on this thing? Okay, this is a serious design flaw on this. Oh, all clear, here we go. So we go 181.3 divided by 7, and I get, I'm going to try that one more time. 181.3 divided by 7, and I get 25.9. All right, so looking here, I have a average miles per gallon somewhere between 26 and 30 miles per gallon. Well, let's take a look at the table or the graph of values. So if I'm looking at this graph, this is approximately linear. So I mean, if I draw a line of best fit like that, that's not a straight line. So let's actually go back a second. And so I'm going to use an actual line tool. So here we go. And of course it's white. That's not helpful. All right, so we can kind of see that white line. Try it again. All right, and so a line of best fit goes somewhere around here. And actually, if I look at this, I could fairly safely say that this point right here, oh my God. I can safely say that this point right here is pretty close to that line of best fit. So what I'm actually going to do is I'm going to take 160 and I'm going to divide it by 5, and I'm going to get 32. I'm going to double check here, so I get all clear, 32, so my goodness. So 160 divided by 5, and that gets me 32. So at this point, I can say fairly safely that car P has better gas mileage on average than car M, because the slope for the line of best fit is higher or bigger than the slope for the line of best fit for car M. And that is exactly what you're expected to do. You're expected to show this calculation and talk about the slope, do the calculations we did here, talk about the slope, and compare the two slopes. So when you are going ahead and typing this out, you definitely need to show, say car P has better gas mileage because, and then talk about how you found the slopes. So that is the expectation on that problem.